Hey everybody, welcome to another Digital Making at Home live stream. I'm coming to you this week from a white void somewhere in the United Kingdom. No, seriously though, I'm in Fen Drayton, same place I was last week. So it's really nice to see everybody again this week. We've got some really interesting guests for you on the show this week. We've got Dave Honnis, who's coming to us from the European Space Agency, so he can talk to us a bit about space and the ways that young people like yourselves can get involved and get some sort of jobs in the aerospace industry, and like through coding and making the things that you're currently interested in. And we've also got Mustafa, another guest who's coming to us from Iraq this week. So long way across the world, different time zones all over the place this week. And so we'll kick off straight away. I'll see if Dave is there. Dave, are you there in the background?
Yeah, I'm here. Can you hear me?
Hey, how's it? Yeah, I can hear you, mate, loud and clear. How you doing?
Yeah, I'm good, thank you.
Awesome. Like I said, little ESA guy behind you. What's the name of the mascot for ESA?
His name's Paxi.
Paxi. Fantastic. Yeah, it's cool. We got one in the office. That's really cool. So how are you, mate? Everything good?
Yeah, everything's good. You know, we're still teleworking. We're slowly, the COVID restrictions are slowly being lifted over here, and soon I'll be able to start going back to the office. But at the moment, I'm still working from home.
Awesome. Yeah, us too. We're still stuck at home at the moment. I think we're looking at going back sometime in September, October, maybe, but we're not quite sure yet. I guess that's the way of the world at the moment, though, isn't that really? Yeah, it's unfortunate. So, I mean, one of the things that you were really instrumental on when you were at the Raspberry Pi Foundation. So, just for a bit of context, everybody, Dave used to work with us at the Raspberry Pi Foundation, and then he moved on to like really big and important things at the European Space Agency, working with ESA Ed, so the education department. So, when you were here with us at the RPF, Dave, you were like super instrumental in getting Astro Pi started, right? Which is that like it's a really interesting competition for kids all over Europe. And that was about 5 years ago now. So how did that happen? Like, how did you manage to get that started and kick off that project for everyone?
Well, there were lots of people who were instrumental besides myself. I was kind of just like the coordinator, really, who just sort of made sure all the work was progressing in the right direction at all times. But it all started kind of by chance, because back in 2014, not long after I'd started at Raspberry Pi, Eben Upton, who's the founder of the Raspberry Pi initiative, sent an email around the office saying that he was going for a meeting with Airbus Defence and Space in Stevenage, and just asking if anyone wanted to tag along. And we were a very small company then. It was only like 20 people or something. And I said that I was interested in going. And we both went down there and spoke to there must have been about 8 people in the room, and then Eben and me. And we were mostly discussing the use of Raspberry Pis in small CubeSat missions. So, putting them on board a CubeSat and launching it. And we were discussing things like radiation tolerance and all kinds of things like that. And we never thought anything of it after that. That meeting came and went, and then the same year, the UK government published this thing called the Innovation and Growth Strategy, which talked about Tim Peake's mission and basically it said that we had to leverage the educational opportunities of Tim Peake's mission as much as possible. And the UK Space Agency were organising all these different space companies to try and make educational contributions to Tim Peake's mission. And one of those was the UK Space Trade Association, of which Airbus Defence and Space are a member. And it turns out that one of the guys that was at this meeting with Eben and I was the head of mission concepts for Airbus Defence and Space. And he wanted to put forward Raspberry Pis being flown to the ISS as the UK Space Trade Association contribution to Tim Peake's mission. And that was when basically I got invited to a meeting with the UK Space Agency, and Tim Peake's mission was on the table. I was kind of completely giddy with excitement. I was basically almost foaming at the mouth trying to compose myself. That meeting was where the idea of a programming challenge for both primary schools and secondary schools first took shape. It was only for the UK at that point, because it was just for Tim Peake's mission. So at that point, my job became twofold. It was partly about setting up the challenge and the competition and the educational offering of that program that students could then participate in, but also about actually qualifying and manufacturing a space hardened version of a Raspberry Pi, which we now all know is an Astro Pi, right? So that was all, and I was getting a lot of help from the UK Space Agency to do that. They were like coaching me and helping me to sort of coordinate who had to write different parts of the documentation. And then Tim Peake's mission came and went, and was a very successful mission. Only like it had like 30 odd educational programs attached to it, of which Astro Pi was one. The hardware, the Astro Pi computers, remained on board the station after his mission. And that's the critical thing, because then ESA stepped forward and wanted to take responsibility for the future of the hardware. And we basically took what had been done for Tim Peake's mission and scaled it up to European-wide for the flight of Thomas Pesquet in 2016. And then every year it's run subsequently every year in September since then.
That's awesome. Yeah, I love Astro Pi. It's one of my favorite things to work on at the foundation. I'm really lucky to be on the team that works on it now. And I mean, I love the term space hardened. What do you mean when you space hardened a Raspberry Pi? What does that really mean?
Basically, there's actually an old blog post you can find actually on the blog. If you go rpf.io/AP5, that will be an old blog post that I wrote ages ago about that subject. But basically, it has to be put into a big aluminium flight case. It had to have all sorts of testing done on it, like EMC testing, vibration testing. The battery in the coin cell battery for the real-time clock had to be vacuum cycled, and it even had to be put inside this chamber and an off-gassing test done on it. So that blog post is a really good sort of guide to what we had to do. But yeah, it took several months, and at a few points there were a few sort of pinch points where it was quite stressful. But it was all fine in the end, and the actual original plan was for them to launch on a Soyuz with Tim. And right before the launch, in about sort of November time, we got bumped off the Soyuz because there wasn't enough space, and we got put onto a Cygnus, which launches on an Atlas V in the US. So we had to almost redo all the sort of launch paperwork quickly, if you see what I mean. So there's a few little moments like that where we were sweating a little bit, but it all got done.
Because the safety aspect is very rigorous, isn't it, to go into space? Like, you have to cross every T and dot every I, like make sure it's all done perfectly before anything can go anywhere near the space station or anything like that, right?
Yeah, exactly. There's a whole review panel, a whole safety review panel, which basically you need to get their authorization to get something called a flight safety certificate for your payload. And without that, you're not going anywhere near a rocket, if you see what I mean. So you have to get this flight safety certificate. You ship it off to, we've got a site in Italy called Altec, who process all the cargo for upload. And they will check all the paperwork. And if you don't have a flight safety certificate, you don't pass the cargo review, and your hardware is not shipped on to the US, where it's going to be loaded onto the launch vehicle.
Yeah, that makes a lot of sense, right? Because I figure once something's up in space, if anything goes wrong with it, it's always like, it's very dangerous for the astronauts that are up there. If there's an electrical fault, or if they get zapped, or if something cuts open one of their spacesuits or some of their safety equipment, like there's a lot of problems that could go wrong. Yeah,
exactly. Yes, and it's designed to do all that. So, and it was actually quite an interesting project, because there was lots of sort of different types of engineering involved in it. So there was there was chemical engineering, physical mechanical engineering, thermal control, and stuff like that, and all these kind of things that I had to sort of catch up on because I hadn't studied them, if you see what I mean. So
yeah. Well, I guess that segues nicely into my next question. Like, how, because I know you had a very circuitous route to getting to work at the European Space Agency, and you used to work for us, and before that you did archaeology at university. Like, that's quite a zigzaggy path to get where you are. I mean, how did you end up at ESA? Like, what was the train of things that ended up at ESA?
I think it was kind of like the right place, right time for me. I was just basically, especially what I said before about the meeting with Eben and that happening fortuitously, and I because there weren't many people in the foundation side of Raspberry Pi at that point. I got earmarked to be the one who basically carried that project forward and was the main coordinator for that project. But I actually was into programming from a school age, and I first learnt. Actually, I have this really great memory of in primary school where we had a BBC Micro, and the whole school had only one, and you were really lucky if you got to go on it. And I have this really vivid memory of the teacher typing in the basic to make it count and print the numbers from 1 to 1,000,000. And it ran it, and then we all went off and had assembly, went off and had lunch, and we came back and kept checking, and it still hadn't finished. And that kind of left me with this kind of impression of what computers are like, in terms of like them being these machines that will just doggedly follow their programming until the end of time, sort of thing. And then it wasn't until I was in secondary school and I learned to program on an RM Nimbus 186, if you remember those. I used a version of the Logo programming language, which I still think today is a really wonderful introduction to programming if you've not done any programming before. And then later on, I got my first proper IBM PC in about '94, mainly to play Doom. But I learned a bit of DOS, batch file automation, and a few things like that. And then in '96, I went to college and studied computer studies, and I learned proper languages like C and assembly. And then I got my first job in '98, which was vetting entire product lines of software for Millennium bugs. And what actually happened was I was working in that career for a while, and I was involved in a company that was bought out by an American competitor, and my job was made redundant, basically. And I decided that I wanted to go off and do something different. So I went to university to study archaeology, and then worked as an archaeologist for about 3 or 4 years. It's a very poorly paid profession. So you know, in the end, I ended up coming back to computer programming because I wanted to have more money. So yeah, that's kind of how it happened. And then after that was about the time when I started finding out about the Raspberry Pi initiative, and they put on something on their website about some grant money to hire new people, and I just sent a prospective letter in. And I always advocate for sending prospective letters, because it means someone doesn't have to pay your agency fee if you put yourself forward and nominate yourself. And that's what I did, and got invited for an interview at Raspberry Pi Foundation. And about 3 months after that, this Astro Pi thing kicked off. So I just completely consider myself lucky, if you see what I mean. There was no kind of flash of brilliance in me or anything like that. It's almost like I stumbled into it, if you see what I mean.
I think you're being a bit too humble there, mate. I think there's a flash of brilliance in you all the time. So, I mean, can anybody work for ESA? Based on that story, would you say that anybody who wanted to could go and work for the European Space Agency and get into aerospace?
Well, it does depend on a lot on you as a person, really. I mean, for me, the way it worked for me is I through Astro Pi, over the years developed quite a set of contacts and acquaintances at the European Space Agency, and one guy basically informed me that he was changing jobs and thought that I would be a good replacement for his role. And then I did the same thing. I sent a letter applying, like, you know, prospectively looking for the job, and then got invited for an interview. What a lot of people don't know is that within a lot of aerospace companies, there are these things called contracting companies. And I'm not actually directly employed by ESA. I'm what they call a contractor. And there's a whole bunch of these different contracting companies. And what they do is they just do your pension, your payroll, your holiday, all your kind of personnel stuff. But you get sent to work at ESA, and you get an ESA boss. And the jobs that are posted by these contracting companies are actually quite, I think, accessible, if you see what I mean. And people just don't know that they exist. People think that you have to apply directly to ESA, but you don't. You can apply to all these. There's a whole bunch of them. There's like HE Space, that's the one I work for. There's ATG Europe, there's Sapienza, there's Vitra CSET, which is one in Belgium. There's a whole load of them, if you see what I mean. And you'll find that the same job appears on all their websites. And so you can browse around them and look for who's got the best paying conditions and things like that. So
it's crazy.
So,
and it's,
yeah.
No, go ahead, mate. What did you say?
No, I was going to say I would encourage anyone who's interested in working in that field to just, you know, go and search and apply for jobs. They look at industry experience as well as academic qualification.
And there's a lot of programs as well, isn't there, for like undergrads and stuff who can go and work with the European Space Agency. You guys offer quite a few things for students and people who are interested in that sort of thing as well.
Yeah. So we've got so ESA Education has a number of educational programs. Obviously, Astro Pi is one. But if you're of school age and you're kind of interested in sort of honing your space science skills, There's a whole range that you can look into. Astro Pi will develop your programming and your science knowledge, but we've also got one called the Moon Camp Challenge, which is where you have to design your own lunar surface base using 3D modeling tools like Tinkercad or Fusion 360. And your base has to be able to be adapted to the lunar environment. It has to be located considering resources like water in the bottom of a crater or something like that. And it has to provide protection for up to 3 astronauts to live there and work on the moon's surface. We've got one called Climate Detectives as well, which is about Earth observation and learning about how you can use Earth observation imagery to understand climate problems. And basically what you have to do in that one, you identify a local climate problem and investigate it and try to propose a way to either reduce the problem or fix it using Earth observation imagery from a number of ESA satellite missions. There's also Mission X, which is about fitness and nutrition, and there you'll learn about like the scientific reasoning behind health and nutrition, and you'll work in teams to do hands-on exercises that sort of develop your strength and coordination and things like that, just like what the astronauts really do. And I've also been working on another project this year whilst lockdown's been going on, which is about researching ways to teach radio communications to young people, which is and we've basically just released a whole bunch of videos which explain how to obtain images transmitted by the International Space Station, which are transmitted over radio. They send like a fax modem sound, and you can use your computer to go onto a website and get the audio and decode it. If you go to the ESA YouTube channel and click on playlists, there's a playlist called Getting Pics from the ISS, and it's all in there.
Awesome. That's cool. That's like that's like a really broad range of things that ESA do, like with the education side of things. It's not all about coding. We just had a question come in, and it says, did you get to watch the rocket launch when the Astro Pi went to the SS? Did you get to see the?
Oh yeah. It was actually that's something I'm really grateful because Philip, the CEO of Raspberry Pi Foundation, just allowed me to do that, if you know what I mean. And it was a very altruistic thing for him to do, and obviously there was no kind of real benefit apart from letting me go and watch it. It was me, Asa, and Jonathan Bell from the trading company who was also really instrumental in the manufacture of the flight hardware. And yeah, we actually watched it, and it was a bit stressful because often rockets that are launching from Florida are quite prone to being delayed by weather or various other conditions. And it actually launched on the day that we had to get our flight back. And right before the launch happened, there was some kind of mains water failure at Kennedy Space Center, and they basically kicked everybody out. So we were like, oh my God, it's going to launch in about an hour. We've all been. So we basically went to the car park, jumped in our cars, drove like crazy people to this bridge over the Banana River, which allows you to just about see it in the distance. And we got there, parked, probably illegally, and ran, and we just saw it disappear into the clouds. It was just a little blip of fire we saw. We didn't actually, and then we heard the noise. The noise just was like, like your whole rib cage is being shattered by the bass vibration of it, sort of thing. So that was a really great experience.
That must have been really rewarding to see. Like, I mean, that's almost like the culmination of all your work, and just watching it like disappear through the clouds. Like, that must have been really cool.
Yeah. Well, there's lots of other things on the rocket also, but it is a cool thing to know that something that was in your hands at one point is now on that rocket and going skyward, if you know what I mean. That was really good, a really good moment. Yeah, probably one of my favorite memories, to be honest.
Oh, that's cool. So, I mean, like, we work at the Raspberry Pi Foundation and we do a lot of coding and stuff. I mean, how important would you say programming computer science is if you want to be involved in space exploration? How much should you like put into that? How much effort should you go through with programming and learning to do those things?
Well, I wouldn't say it's 100% essential because there's lots of aerospace jobs available that don't need programming. But if you are going to follow a technical career of some sort, then computer programming underpins so much stuff that it will just keep on cropping up and cropping up. And if you don't know programming, that's always going to be a roadblock for you, if you see what I mean. So if you study computer science, there's a whole range of technical subjects that you could then go into. you know, at the moment, I'm very interested in like emerging technologies like what do you call it? Machine learning and artificial intelligence. And I think that's going to have a huge impact on a wide range of fields, especially things like, you know, manufacturing, aerospace, things like that. And I don't know if you recently Googled that GPT-3 AI. That's scary.
That's crazy, isn't it?
That's like, it can design websites by
Yeah,
typing in what you want. Yeah. So, but ESA's already got a few artificial intelligence missions. One is called PhiSat-1, which is an Earth observation CubeSat. And it actually uses a trained AI to work out whether there's too much cloud cover to bother downlinking the image. And it intelligently decides to discard an image that's got too many clouds in it based on the you know, the labeled data and the layers of the processing. And we've seen some Astro Pi experiments doing some similar stuff to that. And so I think some kind of specialization with machine learning and artificial intelligence is like is going to be one of the skills of the future.
Yeah, passport to lots of jobs, right, in the future. I think being able to make machines that can learn and pick things up quicker than humans, that's cool. Another question has just come in from a code club. It says, what is your favorite Astro Pi experiment?
Oh, wow. There's been so many over the years, but there was one this year which we just ran on the ISS in April from a French team that was basically looking at the accelerometer data. And what they were doing is they were basically at a high sample rate. They were very fast sampling the values of the accelerometer. And then they were running it through a fast Fourier transform calculation, which is often used in software-defined radio when you've got a radio that's just listening to, say, the measuring a voltage on an antenna. You'll have like a really jumbled signal of all the different wavelengths of radio signals all being received at the same time by the antenna. You'll get all this jumbled like noise basically, and the FFT calculation splits all those out into their separate discrete radio waves and signals so that you can select the one you want to tune into and listen to. And they were doing that with vibrations being picked up by the accelerometer. And I was astonished that they were actually able to pick up a 10 hertz oscillation and its harmonics on the ISS, somehow being translated up the Bogan arm and into the Astro Pi. And we were all scratching our heads thinking, what's this going to be? And I think, I don't know yet, I haven't checked, but it may have been there's a centrifuge in Biolab, which is one of the racks in the Columbus module, which the Astro Pis are usually sort of bolted onto, and that has a centrifuge in it, which may have been spinning, and that oscillation may have been slowly coming up the, you know, and being detected by the accelerometer, which really blew me away. So, and that's kids doing that, you know. That's you know, it's just, yeah.
Yeah, that's crazy. Yeah, we definitely can do that, Trent. We'll definitely pop the YouTube channel in the chat for the ISS and ESA stuff. It's really, really interesting. There's some really great videos on there, so we'll definitely share that with you. That's totally fun. Yeah, that's amazing. Like that's the thing that blows me away about Astro Pi every year is like when you look at some of the projects and they ask me to judge some of them and you see what some of these kids have come up with and the creativity, the ideas and the breadth of like just using this one tool that we have available to us. What can you make it do? What crazy stuff can you find out? You know, like measuring the magnetosphere and stuff like that. There's always crazy stuff people do with it. Like, yeah, it's really inspiring. I wish I was as creative and technically apt when I was there. Right? Like, that would have been incredible.
I know, actually. Well, I've often thought about that Astro Pi, and that's the gold standard of why it's a good program. Because if you're at our age, we think, oh, I'd love that if I was at school. You know, almost feeling jealous of the kids now. If you know what I mean. That's a mark of a really good educational program.
Yeah, it's true. And then moving through into machine learning as well, right? The ability to start doing machine learning possibly in space would be really incredible. So I guess. No, go ahead, mate.
Yeah, we've had a few experiments that use TensorFlow already. We usually get about 4 or 5 a year at the moment. And we actually had one this year, which was very similar to that ESA mission when they were looking at cloud cover and they were trying to train the AI to recognize clouds, different types of clouds. But that's, you know, I think it's a real kind of area that I think we want to develop with the program in the future. But yeah.
Yeah. No, it's true. It's looking forward. That's the thing, isn't it? It's like looking forward with the technology. Like, where is it going? And then using that, because aerospace is at the forefront of all that stuff, right? Like, aerospace is always some of the first industry to use that sort of new technology, and it's got huge amounts of growth compared to a lot of the industries at the moment as well. Aerospace, it's just continuing to tick on. I mean, what in that sense, like, what advice would you give young makers or people who are watching the show today if they wanted to get into aerospace? Like, what would be the key pieces of advice you'd like to give them if they want to do that?
If you're at school age, then look at those educational programs that I was talking about before, the ESA education ones. So Astro Pi Challenge, Moon Camp Challenge, Mission X, Climate Detectives. Look at those. They're really good to sort of sharpen your skills. But if you're at, say, university age, obviously I would recommend that you study a relevant science subject, or an engineering subject. But it's not 100% necessary, because obviously my bachelor's degree was in archaeology. You see what I mean? So, but even something like that shows that you understand the academic world. You can undertake research, and you can write a paper. You see what I mean? So even if you have studied a humanities subject, don't think that it's off limits to you. You know, lots of people do go the academic route, but some people go the sort of industry experience route, which is more sort of applicable to me. But ESA does run a young graduate trainee program, which is a 12-month paid employment contract in one of the ESA departments, and it'll give you loads of really good experience about like what the ESA environment is like. And we actually take a couple of them in the education department each year. And you're eligible for that if you are in your final year of your master's degree, or if you've just finished your master's degree. And you have to also be a citizen of one of the ESA member states or cooperating states. And then to apply, the placements go online in about mid-November every year, and they stay open for 1 month. So in that time, you have to go on the ESA website, find the page where they're doing the applications, and have your CV and importantly, a really good motivational letter, okay, that explains why you want to go and work for ESA and what your kind of like your sort of intention is for your career. And obviously, yeah, that actually potentially will open a lot of doors for you, because there's lots of people working in ESA now who were once young graduate trainees themselves. So when they see that on your CV, they think, ah, yeah, this guy, sort of thing.
Yeah, and it's a great opportunity to, like you say, make those connections with people at ESA and like get involved in the actual context of being there and understand what it's like, and that can open a lot of doors for you too if you're the right kind of person, meeting the right kind of people. Yeah, definitely, that's really cool. Brilliant. Thanks, Dave. It was really great to have you on today, mate. It's like been a long time since I've seen you.
My
it's
pleasure.
Nice to see your face again. But yeah, so again, thanks, mate, and thanks for all your advice. It's been really cool to talk to you. We'll catch you later.
All right, all the best.
Later, mate. How cool is that, right? So like getting to talk to Dave, who works with the European Space Agency, right, helping send astronauts up into space, talking about all the kinds of science they do up there, and helping young people like yourselves get involved and do those sorts of things. So again, we're going to put some links in the chat. We've got all those links that we brought up today. So if you want to have a look at the ESA education website, you can do that. Definitely go and check out their videos on YouTube, because I had a look at most of those. Those videos are amazing. And there were some really cool projects I didn't even know ESA were doing that Dave talked about there, like the designing your own moon base one. That sounds ace. I love a bit of Tinkercad, so I might jump on and grab the boys and do that one later. But we've got another special guest this week, and he's coming to us from Iraq. He sends in lots and lots of his projects to the Digital Making at Home channel every week. We love seeing his work. Basically, every time we release a video, Mustafa throws out his work at rpf.io/home. We get to see it, and he's done some really amazing stuff. So we'll get him on now. We'll see if he's there. You there, Mustafa?
Hi. Hi, everyone.
Hey, how's it going, man? How you doing?
I'm fine, thank you. How are you?
I'm good, thanks, mate. It's really nice of you to come on. I know it's been a bit of a hassle for you, and it's a bit later for where you are, isn't it? It's like, I think you're an hour or 2 hours ahead of us where you are, so it's different time in Iraq.
4 hours.
4 hours, cool, man, crazy. So whereabouts are you? So I don't know Iraq very well. Whereabouts in the country are you at the moment? Where do you live?
I live in Baghdad.
In Baghdad, in the capital?
The capital of Iraq.
Amazing. That's really cool, dude. That's awesome. And so are you at school right now? Are you going to school?
No, because coronavirus.
Oh, of course. So they've sent you all home. You get to be at home. And does that mean that you just watch television all day long, or are you having to do schoolwork at home as well?
Okay, I wake up, I play in my iPad, and I finish my homework and make anything. I play soccer. I like soccer very well,
Awesome, man. That's really cool.
and I sometimes I coding.
Yeah, sometimes coding. Because you've done quite a bit of coding. I mean, you always send your work to us, which is really awesome. So like I love seeing the work that you send in. That's really, really cool. And we just wanted to say thanks for sending all your work in. It always cheers us up when we see your projects come in. But like what's your favorite subject that you do at school? What's your favorite thing to do at school?
It's math.
Math. Yeah, I love a bit of maths as well. It's some people find it a bit tricky, but I think maths I like the idea of numbers, right? They just make sense to me. Numbers are things that make sense, I think, and that's really cool. Do you use your maths in coding a lot?
Yeah, of course.
Yeah. Yeah, it's definitely good for that. And so you go to code club, right? You go to a code club to do some of your coding learning. Is that right?
Yes.
Yeah. And where do you do that? Are you doing your code club from home at the moment, or is your code club off as well because of coronavirus?
In the home.
Yeah, you do it at home?
Yes.
Awesome, man.
Because
That's cool.
coronavirus.
Yeah, of course. And so so what other coding projects have you made? Did you do anything like, have you done Astro Pi? Did you do the Astro Pi project?
Yes, of course.
Yeah, that's awesome, man. Was it the Mission Zero one that you did?
We did it in Iraq.
Yeah. Was Mission Zero, yeah?
Yes, in Iraq.
Yeah. And you did that. So that's all in Python, isn't it, Mission Zero? That's textual coding rather than Scratch, which we'll do today.
Yes, we use Python.
Yeah. How did you find working in Python? Was it hard or did you understand it quite quickly?
It's good. Because textbook programming.
Yep. It's the next thing, right? So Scratch is here and then Python is like up here, a bit harder.
Yes.
Yeah, cool. So we'll do some Scratch stuff today, shall we? Should we do some Scratch projects today?
Lost in Space.
Lost in Space, right on, man. Exactly, right? So we'll do the Lost in Space project. So do you want to switch over to your Scratch screen for me?
Before.
That's all right.
Okay.
Fantastic. Cool. So before we start a new project, did you have any projects that you would like to show us that you've made? Is there anything special you'd like to show everybody that you've done recently? Wow, that's loads of projects.
This is living and non-living. Join between sides.
Oh, right on. Oh, that's cool. So it helps you classify things into living or non-living organisms.
Join between sides. I joined between size and coding.
That's really cool. And how did you get it to decide whether it was living or non-living? How did the code for that work?
So first, I program when I clicked the green flag, go to 4 and the Y 100. It's for balloon X and Y.
That's cool.
Forever, if sprite 1 go to this position, start sound pop. If the balloon go to go here, start sound pop. If touching sprite 2, start sound clapping. The sprite 2 is not living, so the balloon is not living.
Oh, that's cool.
Okay.
That's awesome, man. So you drag it across, and if it's touching the one that says not living, it's good. And if it touches the one that is living, it says bad. That's cool, man. Well done. That's a great project. You've got so many projects, Mustafa, so many different things that you've done. You must be very busy with your coding.
Yes.
Yes.
That's cool.
So,
Wow, man, you've got so much work. And I see lots of people look at your work as well. So you share your projects and lots of people like and see your projects too. That's really cool.
Yes. Okay. Thanks.
Well done, man. That's awesome. So should we start doing a new Lost in Space? Should we open a new one?
Yes.
Excellent. Let's do that. Let's open a new one.
Okay. First of all, I have to delete the cuts.
Yeah.
And I go to choose a sprite and choose the earth. Okay. When I see earth, I will put it in the corner, like this. Okay, after that, I will go to choose a sprite and I will search about a spaceship. After that, I will go to custom and like this. Okay. Okay, first I will go to choose a bug drop and choose the stars bug drop. After that, I go to events to start programming the rockets. I will choose when I clicked points in direction 0 like this. Okay, point in direction 0 and I will choose go to X minus 150 and Y minus 150. Okay, I will test my project. Okay. After that, I will go to looks and choose the say, and I will write and I change the hello to let's go. Okay. Okay, let's test our project. Okay, just he say let's go. After that, I will go to motion and choose point towards earth. Okay, let's test our project. Okay. After all this, I will go to glide and put it here and change, and I put in the X 0 and in the Y 0. So when I put 0 on X and Y, the spaceship will go in the center. Let's see. Okay. Why it's go to center? Because I say x0 and y0. When I want to see y, I will choose this a bug drop. Let's see. Just okay. It's in the center. In the center. In the center.
That's very clever.
Okay. After that, I will delete the glide. I will delete the glide, and I will go to control and choose the repeat. I will make the repeat 200. Repeat 200. But I will test 10. I will test 10 seconds. What's has happened? I go to motion and add move 2 steps. Okay, let's see. Okay, when I say repeat 10 times, it's very slowly. I will make it 200.
Very cool.
Okay, I will add animation in the spaceship. First, I go to logs and change color effect by 25. So I will go to customs and delete all customs, and I will make duplicate for this custom and go to this and delete. Delete the fire. Like this. Okay, I finished.
You have a very steady hand, Mustafa. You're very good with the mouse.
Thanks. Okay. I will choose next custom block and put it here. Let's see.
Awesome. That's so cool.
So I can't see the next custom. I can't see the fire hide and show. So I will go to control and choose weight. Put it here. I make it 0.05.
Awesome. That's cool, man. That's really good.
Okay. After all that, I will go to logs and go to change size and set size. The rocket, the size of rocket, it's 100. So I will put set size 100 and change size by -2. Okay, it's very smaller. So I can put minus 0 point minus 0.5. Sorry, I have to put minus 0.05.
Mhm.
Let's go.
That's cool. And it's shrinking now. It's like going away from us. Looks like it's going towards the planet. That's wicked.
Okay, after that, I will go to choose a sprite and go to animals and choose the monkey. The size of monkey is very big. I will make the size 70. After that, I will go to customs and and make it white. Make the outline white. So I will go to the circle
Hmm.
and make. Okay. After that, I will add something. It's the oxygen. Just okay. The programming, I have to go to events and choose when it clicked. Go to control, choose forever, plus go to motion and choose the turn and make it 7. Okay, it's good. I will make that for Earth also, but I will make the turn is 1 to be slowly.
Okay, so the smaller the number, the slower it will turn.
Okay,
Right,
yes,
right. Cool, cool.
yes, of course. Okay, after that I will go to choose a sprite and choose the rock sprite. So, this rock, I will put it in this position. I will go to events and choose when it clicked, go to motion, point towards Earth. Point towards Earth. After I will choose forever and put it under the point towards. And choose move 2 steps and I will choose if on H bones.
Awesome. That's super cool, man.
Okay, I will go to choose sprite again and I will choose star sprite. Star. This the star. I will put it in this position. Okay, I will go to events. When it clicked, forever repeats. Repeats 20 times. 20 times. Okay, it's good. So I will go to logs and and I will put here change size by 2 and change size by -2. Okay, let's see.
Oh wow, it's like it's twinkling in the sky. That's really cool.
Okay, I want to add something. I want to add a sprite, but this sprite is not in Scratch. So I upload from Google.
Hmm.
I will choose the parachute sprite. This and first I will put it in the corner here. Far. I will put it far. Okay. First of all, I will go to events. When I clicked, go to logs and put height. When I clicked height. Okay, after that, I will go to choose a buggy drop and choose a blue sky buggy drop. So I will go to buggy drop and choose the star buggy drop. Okay, awesome. Okay, I will go to any sprite, and put. When I clicked, switch buggy drop to star. When I clicked buggy drop to start like this.
And that can be on any one of the sprites. It doesn't matter which one, any sprite.
Yes, any
Okay,
sprite.
okay. Cool.
So I will go to spaceship and I will go to control and choose if. I will go to sync and I will choose touching. If touching Earth, switch buggy drop to blue sky. Okay, good. So I will go to all sprites and put. When I clicked show, because I will save for all sprite height.
I see.
Show. So I will go to Earth and go to events and I will choose when buggy drop switch to blue sky height.
Ah.
I will make a copy paste for all sprites. Just I will leave the parachute sprites. So yeah. Okay, I will go to the parachute sprite. Just when buggy drop switch to blue sky show. I'll put it here. Just see.
And so we're waiting for your spaceship to come up and touch the Earth now, aren't we? Once it touches the Earth, everything will change, won't it?
Yes. Okay.
Ah.
I have to stop the project and go to motion. And I will put the parachute here. And I will go to glide and put it here.
Oh, I think I know what's going to happen. I think I can predict what will happen. That's very cool. We've had some people ask if you can add another planet to your animation as well, Mustafa.
Yes.
We'll do that once we get your parachute man sorted out. That's really cool.
The parachute man, when I switch the buggy drop to blue sky, I see the parachute man here. Why? First, I will put it here. And when I clicked, go to X and Y.
Cool. Yeah, I get it. So that was because we didn't tell it to do that at the beginning, right? It was already where you put it before.
Yes.
I get it.
It's a problem solving.
Yeah, very much so. No, that's very clever. And then touch and change.
Okay, I want to add something, but Just so. I will go to parachute and go to customs, and I will choose this. Okay, I will convert, and I will draw Raspberry Pi logo. Okay, green color, green. Just a minute. Green. Mm.
That's awesome. So while we're waiting for this, Mustafa, so when in this part here where we're moving, do you think we could add another sprite that does something else? So we could add, like, someone asked us to add the special planet one, I think. If we can add a planet to your animation, they'd like to see if you could do that. There we go, planet 2. Hey, Parachute Man, that's awesome.
Okay. I will go to choose a sprite. No, there's no. Okay. Okay, I'll go to sprite and boom. Okay, I'll make some. Okay. Okay, I will go to custom and I will make it red. Okay.
That's cool. So now it looks like our rocket is taking off from one planet and flying back to Earth, and then our little man comes and lands on the planet as well. That's really, really cool.
Okay. Okay, I will add a clapping sound.
The monkey spinning and our star growing. Wow, our star's really big now. Hey.
I must think when buggy drop the switch to blue sky height.
Yeah, yeah.
Height. And when you click show. Okay.
Very cool.
I finished. That's all.
That's cool, man. That's cool. Well done. That was awesome. Thanks, Mustafa. That was really interesting to watch, man.
Thank you.
I love the way that you made the parachute, man. So like it added on. So you finished the animation that was normal, and then you had the extra parachute man that came down. That was really, really cool. I love that. That was really funny. And I think the way that you sort of showed everybody your process, the way you explained to everybody was really, really cool, man. Thank you for that. That was a great lesson. It was really good.
Thank you.
No, thank you, man. Thanks for coming on. It's really cool. So
okay.
Go ahead.
When I finish, I can say I help this guy because he lost in space. I help this guy to bug in air.
That's super cool. Did you draw that?
Yes, I drew.
That's amazing, man. That's awesome work. Well done. That's so cool. I love it. Is that a satellite as well above the spaceman?
Yes.
Satellite, very cool. And a rocket ship and a couple of planets. That's so cool, man. Well done. That's excellent, man. Really cool. Thanks for coming on today, Mustafa. It was really amazing to have you. Really, really nice to have you, man. I hope we can have you back again in the future.
Thank you.
No, thank you. All right, we'll catch you later, man. See you later.
Goodbye.
Bye. That was cool. How cool was that, right? So it's not just you guys here who are in England. There's people all over the world who are doing stuff with us. And if you've got things that you would like to share with us, please do. Please send them to us at rpf.io/home. That's how we met Mustafa, and that's how we invited him to be on the show. His drawing was amazing, wasn't it, Rachel? What a great piece of work. How cool is that? Like, what a dedicated little guy to keep making code and then draw pictures and do all this really awesome stuff that he's doing. He's an amazing coder. I'm sure he's going to go very far in life, that young fellow. So again, everybody, if you're watching and you want to share stuff with us, rpf.io/home. We're making new content every week for you to get involved with, so you can jump in and watch our videos, and we do those every single week. We're also looking for you to share things. We do the live stream. There's lots of stuff that we're doing for you at home. So please keep getting in touch with us, and we'll see you next week. Catch you later, everybody. Bye.